Hey, what's up, fellas? Today I'm doing an experiment on some Crucible repair paint. This is basically just outdoor fireplace fire brick mortar, and it's some pretty decent stuff. It's a water glass based material, sodium silicate, and I thought I'd give it a try to see if it could repair a broken crucible that I have. I went ahead and painted them all. I'm going to be testing them all, but let's take a look at this. Because this is a sodium silicate based refractory adhesive, basically, we're going to use the CO2 gas from this pellet stove to rapid cure the sodium silicate and also take advantage of the heat to vaporize off some of that moisture. So we're going to cure them like this and see how it goes. Okay, so my first impression on how this process went is I feel like I probably should have sandblasted these crucibles because all of them already kind of had an old crucible protective coating test that I did. This one here cracked on me, and I heard it crack when I opened the grill. It was a very sharp ping, but I'm going to test this one first to see the effects of that. This right here is a silicon carbide crucible. Same with this one here. And I feel like it adhered very well to the substrate, so we might have something here. In this test, I'm going to be making 2 pieces of round stock using some iron tubes that have been painted on the inside with a little bit of sand on the bottom there. And the furnace has a yttrium oxide high emissivity coating, and yttrium oxide has a attribute known as thermoluminescence, which causes heat energy to be converted into light, and I'm hoping maybe that increases the furnace temp a little bit and makes it a little bit more effective. We're going to be using some very thick, nasty waste oil for this test. The previous thermal coating that I had on this crucible should have been sandblasted off. I can feel that this layer has delaminated a little bit. When you flick it with your fingers, it gives that hollow sound. But I'm going to test it in this condition anyway, just to observe how important is it to make sure you get a good adhesion. It might not matter. It might just melt right back to the surface and be okay. So that's one of the things I'm testing in this particular run. Oh, that's terrible. Okay, so the broken crucible test failed us. And it broke. We got a problem there. Hopefully we can get all that crap out of there. So I'm basically just going to have to let this thing cool down completely on its own and see what we can do to get all that out of there. We got molten metal at the bottom. So yeah, that completely and totally failed. All right, so it went elephant's foot on us there. Big old blob of metal came out of that. I think we'll be able to get it out of there pretty easily though. All right, so that didn't work out so hot at all. There's the massive elephant's foot. That fell down into the bottom of the furnace. This is the other piece that fell out of the crucible directly into the furnace heating zone. Got a lot of trash in that this time around. This crucible had a bunch of another type of coating that I had tried all over the outside of it that appears to have stuck onto some of this, even vitrified in some cases. Right there, that's completely vitrified. You can see it here. This was a crucible shield paint that I had put on there to kind of help prolong the life of crucibles a little bit. This crucible was cracked when I painted it. This is a fire clay crucible. They're very durable. This thing has been used like maybe 50 times. It's had a pretty horrendous life. We have completely delaminated, but as I said, I wanted to do an experiment on this one to see if the delamination was a result of the prior coating, and it appears that it was, because you can see here we have that prior coating material on the back of the shielding substrate. So we're going to try this out. We only need about 8 minutes to melt this. It's a big old trashy pile. I need to go get my spoon, get all the crap out of it. It's a little too hot. Here we go. Oh shit. What's up with that? Alright, so that sucked. It bubbled up on here too, but again, these crucibles were not treated on the outside. I don't really see a whole lot of that delamination on the inside. I dropped a piece of brass in there. So this is not a very good recipe. The freaking rain is coming. You can hear the thunder. I'm gonna wrap this up and we'll take a look at what we got going on here. All right, so it was kind of a disaster. The inside of the crucible seems to have done okay. No notable delamination. The outside, however, bubbled up in a couple of spots. And again, these crucibles were not completely cleaned. That's right where the flame was hitting the crucible. I'm gonna call that a fail. The delamination's a no-go. This is what I got out of that. Got myself a nice piece of brass round stock. This has been turned down on the lathe. This is what they look like before you turn them down on the lathe. They won't come out of this pipe without cutting it. Got this for later. But yeah, that was a fail. We won't be doing that again. So now you know. This material is refractory mortar for outdoor fireplaces from Menards. Ironically, it says do not use outdoors, even though it's for outdoor fireplaces, which I find incredibly stupid that they would call it that. But yeah, man, this is a fail. It wasn't a very good melt job either.